discovered by Sir Humphry Davy in England in 1807. He was conducting experiments in his lab one day, and by the time he was finished with the experiment, he had completely isolated sodium. Until the 19th century, there was no distinction from sodium and potassium because no one knew the difference between vegetable alkali and mineral alkalis. In order to discover the sodium, Sir Humphry Davy used electrolysis of very dry sodium hydroxide and collected it at the cathode. Sodium cannot be found isolated in nature because it is so easy to lose one of its valence electrons, so it combines with other elements. In fact, it is so severely reactive with air and violently reactive with water that if it isn't kept in special oils, it will immediately oxidize with oxygen and mix with water to form salt. It's from the English word soda, and the symbol Na comes from the Latin word natrium, or defined in English as natural salt. It is a silvery white solid metal that is in group 1 or the alkali metals. An element classified as an alkali metal is a very reactive metal that does not occur freely in nature. Its atomic weight is 23 and its atomic number is 11. It has a boiling point of 1156 Kelvin and a melting point of 370 and 87 Kelvin. Its density is 968 kilograms to the negative third power. Some of the things you can use it for is salt, metal making, petroleum, and soap making, and much more. You can find it on the very left of the periodic table of elements. Some cool facts about sodium are that sodium is one of the most malleable metals on the periodic table of elements. Also, sodium takes up about 2.7% of the Earth's crust. Sodium also makes up most of our oceans, lakes, rivers, saltwater ponds, marshes, and other saltwater bodies on Earth. Without sodium, humans, animals, plants, and all living things wouldn't exist because it is needed to make electrostatic charges on cell membranes, so we would not be able to sense things around us without it. We do not own all of the photos in this video. Thanks for watching.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium, and lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.